we now come to the third part of opportunistic mobile networks. So, here we will continue from what we had previously. So, we were discussing about exploration due to human mobility, purposeful exploration and so on. So, these are the things that we discussed last in the second part of Wayman's. So, let us look at this particular figure. So, what we have over here is a region that has been segmented into different square like zones of equal size. The size of a zone is basically the side of a zone. So, these are the different zones, right. So, it is the entire region has been segmented into different zones, the square shaped zones, and the side of the zone is equal to the transmission range of an internal node. And recall the concept of internal node and the external nodes that we discussed in the context of moons when in the second part of the lectures. And so, here also we talk about the concept of k left zones and 1 near zones. So, let me just explain this to you first. So, for any zones we have number of zones over here. Here let us consider this particular zone. So, one or rather let me I think this is a better example. Let us consider this particular zone. So, k left zone. So, if k equal to 2 for example, then 2 left zones would be these 2 zones. Then we have another concept, the 1 near zone. So, for this particular zone, the 1 near zones are this zone, this zone, this one, this one, this one, this one, and this one and this one. So, we have around this all these zones which are 1 near zones. So, similarly, so instead of 1 near, one can go for 2 near and so on, and all these things can be extended further. And there is another concept that is the frequency of visit of a zone. So, all these things, these terminologies are going to be used in order to understand further about how these moons function. So, I already mentioned to you that in the case of moons, human exploration is something that is very important. So, we have human beings who walk around maybe using TLW, the truncated Levy walk model, or any other model. Human beings who they move around, not only that they move around, but they also apply their intelligence. So, there one can come up with different schemes of intelligence. So, we basically considered some basic forms of intelligence like the ones that we see over here. So, we use 4 different forms of intelligence: L1, L2, L3 and L4. L1 basically is on learning about the location of a stationary node, visiting that node. So, that becomes the first scheme which can be used for rescuing a particular victim by a rescue worker. L2 is another scheme that can be used for a similar purpose. So, which is basically that not only you perform as in L1, but also you visit a randomly chosen zone from the stationary nodes 1 near zones. L3 is L1 plus visiting the stationary nodes k left zones. L4 is L1 plus visiting the stationary nodes 1 near zone. So, these are the 4 different schemes that can be adopted, different human intelligence based schemes that can be adopted by a rescue worker to go around in search of different victims. So, like this actually one can come up with different other schemes as well. So, it is not that these are the only 4 schemes. So, we had considered only 4 schemes, but this could be adopted by adopted and extended to different other schemes as well. And this is what we are going to use in our study and see that how these schemes they compare with one another. So, we already have seen that purposeful mobility is very important, and an internal node's mobility is controlled in order to achieve the different mission objectives. So, that is where the purposeful mobility aspect of Rao and Cassidis that was proposed in TMC in 2004 has been adopted. So, and for a stationary node xy, so stationary node means it could be a victim, it could be the stationary node could be a relief camp or something like that, which is relatively stable over time. So basically, what happens is these values, the locations of the stationary nodes, they can be stored in the different databases, and these locations can be shared with the other nodes through different applications. So this is basically the structure of a particular moon node, and every moon node basically has this kind of architecture. So it has a database which stores the location of the different other nodes, and that can be basically informed to the other nodes with which it is going to encounter. So we will just look at how these schemes they compare in terms of simulation based experiments that were performed, L1, L2, L3 and L4. So how they compare. So so in our simulation we had used the one simulator, and we had simulated a terrain size of 5 km by 5 km, and where number of nodes that were used were 13. So in one experiment 30 mobile nodes and 60 stationary nodes, and in another experiment 20 mobile nodes and 45 stationary nodes, and the speed of motions are also as shown, and the simulation durations of 12 hours and 24 hours, and the mobility model that was adopted was just the plain basic random waypoint mobility model. So so as we can see over here, that compared to the random waypoint mobility model, the schemes L1, L2, L3 and L4, these schemes they perform better in both the scenarios of 60, 30, 24 hours. So 60 nodes, 30 nodes, so 60 stationary nodes, 30 mobile nodes, etc., and 45, 20, 24. In both of these scenarios we are able to see that in terms of the number of encounters, basically these schemes, these intelligence based schemes L1, L2, L3 and L4, they perform better compared to RWP. So this is with respect to the different speeds, the speeds of the mobile nodes, and here also we see that the total number of encounters per mobile node with clustered stationary nodes increases under the intelligence schemes L1, L2, L3 and L4. So this is these are the basically the different schemes and their comparison with the RWP, that means the random waypoint mobility model. So the number of encounters, as you can see, are better. So you get when you apply. So in other words, I mean, what does it mean? So this means that the number of encounters is more, means that by adopting these intelligence based schemes, one can these nodes, they can come more frequently in contact with the stationary nodes. The mobile nodes can come more frequently in contact with the stationary nodes compared to the basic mobility model of random waypoint. Actually, in this particular paper, the authors they did not consider the truncated Levy-Walk human mobility model, so that was not adopted. So the basic, the stochastic RWP, which we have studied in the context of mobility models when we were talking about ad hoc networks, pure ad hoc networks mobility models, we already know about what is RWP. So it was it was compared with that RWP. So in terms of the percentage encounters with the stationary nodes, here also we find that although there is not too much of difference, but still percentage encounters with the stationary nodes in this particular context of adoption of L1, L2, L3 and L4 is better compared to the use of RWP. And I mean, because the legends are the same, I do not need to explain this again, but this stands for RWP and this for L1, next one for L2, L3 and L4 for the different scenarios 60, 30, 24, 45, 20, 24, 60, 30, 12 and 45, 20, 12. Another important observation was by adopting the schemes L1, L2, L3 and L4, we get better frequency of zone visits compared to the use of RWP. So RWP basically, as we can see from this heat map, that here the tendency of the nodes is basically to come towards the center, come towards the center. So the center basically has more frequency of visits of the nodes compared to the other schemes, L2 has little bit more flatter distribution of the nodes. Then L3 is even better in terms of the flatness of the distribution of the nodes, and L4 looks even better. So it has even better distribution of the nodes across the entire terrain. So the observation is that the human intelligence basically increases communication opportunities of the mobile nodes with the stationary nodes. So human intelligence means these schemes L1, L2, L3 and L4. So this is what has been termed in the literature as human intelligence in this particular work. So the next observation is that the induced purposeful mobility basically provides greater communication opportunities to the network zones, and this is basically not something that is specific to our work. So Rao and Kesaidis had already observed it, and they came up with their own solutions and own models towards that, in line of that, and we have simply adopted it and we have used it in this particular context. Now, another important issue is heterogeneity in moons. So in moons, basically the nodes, they exhibit different types of heterogeneity. Heterogeneity with respect to the different network interfaces, So A and B, they have different network interfaces. This is what is shown in this particular figure. C and D, C is using a different routing protocol from D, and they come in contact with each other. So if they are using different routing protocol, how do they handshake with each other? Then this is an example where the transmission ranges are different. So two different mobile nodes, they have different specifications, consequently their communication ranges could also be different, right. So so this is again something that was studied by Saha and Mishra, that means in our group itself. In our research group, we have worked on this, and this was published in the IET Networks in 2013. So issues of heterogeneity in opportunistic mobile networks. So in terms of heterogeneity, basically, so these are the things that have been studied. Representation of the different nodes, set of nodes is represented as V. So these moons basically can be represented as time varying graphs, where each of these graphs have a set of nodes V, a set of edges E, the time lifetime of the system T, then there is something called the presence function, which is basically E cross T, and which basically maps to E cross T, and then L, which basically corresponds to the latency. So the communication degree of a moon is defined this way, that it is the ratio of the set of edges between the nodes with compatible routing protocols to the total number of edges. Routing incompatibilities. So basically what happens is different protocols might be used by the different nodes in forwarding the messages, right. So consequently what happens is there are routing incompatibilities that might arise. So so how do you deal with such incompatibilities? So basically protocol specific headers have to be added to the messages when they are created, and so these protocol specific headers basically make it difficult for these messages with different protocol headers, protocol specific headers, to talk to each other when they come in contact with each other. And the second thing is that the operation modes of the protocols, for example, so one protocol might be following a single copy routing, another protocol might be following a multi copy routing, and the differences in forwarding and replication criteria could also be different, and consequently there are different routing incompatibilities that might also arise. In terms of the effects, what is going to happen because of these incompatibilities? There will be loss of communication opportunities, there will be undelivered messages, and there would be increased delivery latencies. So, so basically this is something that we had proposed. We proposed the use of protocol translation units, PTUs. So so let us say that two different protocols, SNW and Prophet, two nodes following two different routing protocols, SNW one using store and wait, the other one using Prophet. So in between we are introducing devices which will run the protocol translation unit, and what is going to do is it is going to act as a translator between of the messages that are transferred or sent by the nodes from the different the different nodes which want to communicate with each other. So this will act like a middleware sitting in between these two different nodes, acting as a translator of these different messages, so that they can follow the messages sent by these different nodes following the different protocols. So, just in a nutshell, this is something that is there in the corresponding paper, which is listed at the end of the slides. Here basically what we observe is, if we look carefully in terms of the percentage of messages delivered, when one is using the protocol translator along with the regular scheme, so the percentage of messages delivered basically increases. On the other hand, if it is not used, then the trend is that as the number of or the percentage of incompatible devices increases, the percentage of messages delivered decreases, and it increases in this particular case. So basically, then the use of PTUs basically increases the chances of message delivery. Now, here basically what is compared is again with respect to percentage of messages delivered, but how the different routing protocols they perform. So, comparison between the pure profit and SNW and PTU. So, under different scenarios, 12 hour of running profit, 12 hour of running SNW, 12 hour of using the PTU based scheme, and so protocol translator unit being used, and so on. So, what we find over here, if we look closely at these plots, we find that the PTU based schemes they perform better compared to the pure SNW and pure profit. So, this is with respect to the communication degree, which was already defined earlier a few minutes back. So, what we see over here is, as the percentage of nodes increases, the communication degree basically goes down, and with respect to the different for all the different schemes where there is no PTU used, where 5 PTUs are used, and where there are 10 PTUs that are used. So, what we see is that when more number of PTUs are used, then the communication degree in general is better compared to 5 PTUs used and 10 PTUs used. Societal impacts is very important. OMNs are one of the prime reasons of use of OMNs is to serve different social needs. So, OMNs perhaps are the only mode of communication after a large scale disaster, because ad hoc networks are better, but not as much as better than pure wireless networks like Wi-Fi or cellular networks, but OMNs are even better than the ad hoc networks. So, and also in the case of rural healthcare scenarios, in rural healthcare basically what happens is so there is lack of connectivity between the different nodes. So, basically the villagers they come in contact with the doctors in the city only after several hours. That means that maybe once in a day a particular villager will be coming in contact with the doctors, and then the entire day will pass, the next day will pass, and again the chances of getting in connectivity with a particular doctor by a villager would happen. So basically so these networks are again they basically perform they exhibit the properties of moons, they exhibit the properties of OMNs in general. So, in case of OMNs basically exhibit lot of use, they have lot of advantages of being used in the case of post disaster rescue operations, rural healthcare, and so on and so forth. There are different other societal societal applications where these networks can be used. So, with this we come to an end. So, these are the different references. All the references are listed over here. So, one thing I would like to mention over here is we have covered the topic of opportunistic mobile networks in 3 parts: part 1, part 2, and part 3. So, not that the audience should note that the students should note that not that all the parts are going to have all the references, but all the references can be obtained by looking at the references at the end of each of these three parts. So, all the three parts taken together and their references taken together, one would be able to get the references. So, another thing that I would like to mention at this point is opportunistic mobile networks is a little bit more advanced topic, and that is so basically what happens is, because it is an advanced topic, it is more likely to be of interest to audience who are in the PG level, the research scholars and so on. And but at the same time, because here actually what we have done in these lectures, as you have seen, that we have given lot of research, lot of concepts which can be used for the research and so on. So, this is a very important, a very hot topic currently, because of the reasons that you have seen. It can be used for different societal applications, it can be used for serving different problems in the society and so on, rural health care, post disaster relief operations and so on. So, there are likewise there are actually many other different applications of OMNs. And the last thing that I would like to mention is that many of these references that you will see, you must have also noted actually when I was covering the different concepts, is I was referring to our own works. The reason is that many of the works that have been done on OMNs worldwide have actually been done by us, but obviously there are other groups, research groups worldwide, which are also very active in OMNs, but we have also done a lot of work on OMNs which we consider as very significant, very much fundamental, and these have been published in very reputed journals and conferences. And so that is the reason actually we were referring to these, because these are fundamental in nature, and that is what I wanted the student to learn. And I am sure that this particular lecture will be of interest to students who are more who have more research orientation, like the PG students, like the research scholars and so on. Thank you.